Alright, we will introduce or talk about more on riveting gun with spring retainer and the set or during our practical session. But this picture shows you this riveting gun. And there are various retainer and setting case set for various. Actually, we only have two. The sun or flush rivet and the universal head rivet. So we will use different upsetting head. Okay, we'll talk about more on our practical. Same thing goes to a bucking bar. Alright, so there are various shapes and sizes on bucking bar due to aircraft work obstruction. There's a lot of obstruction when we carry out aircraft maintenance and repair. Alright, so the various bucking bar are designed and manufactured for different working conditions. Alright, so now can you identify the types of rivets installed here? And we'll talk about the jogger. You may look at here. This is the jogger. Okay, the jogger. So actually you look at the jogger part here. This part is flush with the attachment here. This is the attachment here, and this is the C channel. Okay, C channel. So this is a lightning hole. Alright, so if you don't do a jogger, when you install the fastener onto the two work pieces here, then you actually will form a gap, right? You will form a gap. Okay, let me see, do I get my drawing? Get my pen. What do you mean by that? Okay, let me draw here. So this is the plate which is here. Okay, this is the plate I'm drawing. Okay, this is the plate. Okay, this portion here is actually this. Alright, so what I'm going to draw is this. Okay, which I use another color. Let me get my color. Okay, I will use blue. So what I'm going to draw is this. Okay, I'm going to draw here the jogger. Okay, sorry, not straight. So actually, when you carry out a correct jogger, right, you will actually. So you realize that, sorry, a bit too thick. You realize that when you have a jogger, this is the jogger part, then your pieces, two work pieces, right, where surfaces will actually flush together. So when you install, there's no gap. So what my question was, if let's say you can draw again, let me use the red. Alright, same thing. This is still the same wood piece here. Okay, this is the pieces I'm drawing, and change it to another color. So if I do not have a jogger, actually what will happen will be, you realize that there will be a gap. Okay, underneath. Okay, so this portion here is actually the skin of the aircraft. So you realize that when you install your rivet here, subsequently there's a gap. So this is the gap that we have to fill up in this case. Okay, let me see, I can highlight. Yep, this is the gap. This is the gap. So if you carry out joggering process, then you do not have this issue. But if you do not want to do joggering, or they didn't put into that consideration, then how can you solve the problem? Earlier I mentioned, to fill up the gap, you can put a shim. Alright, you can put a shim. Measure the thickness and look for a shim. Install a shim. So what is a shim? You can go and Google metal shim. Or you can measure the thickness, gap, and fabricate a metal piece. That's another method. Alright, so come to it, how will you measure the gap? Okay, think about it, how you measure the gap. A ruler, or have you heard about feeler gauge? A feeler gauge. Okay, what is a feeler gauge? Feeler. quite filler gauge. So here are the various rivet defects after installation. You can run through it yourself. I think your notes will have it. But then again, what would you do if you have such defects? Most of the time, the rule of thumb would be you have to remove the defective rivets and reinstall a new one, provided it is a rivet damage. Okay, if it's a rivet damages. But if it's a sheet metal or the skin itself, there's a mark, shape, or scratches or dent due to a riveting, then the whole fitting depends. If it's a fitting or skin, will have to discard and replace a new one. Okay, so uh, improper work technique that resulted in defects or damages on the aircraft structure, which will be very expensive. All right, of course, the cheaper method, if let's say minor defect will be rivets and we can just replace the rivet, that is considered okay. But imagine you install 100 rivets a day and 99 rivets you need to replace. So it's not just the rivets costing, it's also the time you spend. Okay, 100 rivets may take you about half a day. So, and 100 rivets you install, remove 99, and to remove and install again takes another half a day or more. So you can see that time is also a factor. So we always believe in do the job the right time every time. So to minimize wastage and time constraint. Here are some more sample of the defective rivet install. Like we mentioned earlier, those defective rivets, we have to remove them and reinstall a new one. So let's run through some defects here. Hole too large in this case. That means you choose the wrong drill bit number and created a bigger hole. In this case, then sad to say that the entire workpiece will have to be replaced, or you have to redo the whole repair. So it can be very expensive lessons. For this, the age gap. What is the possible scenario that create this issue? Well, if you have a age gap issue, chances are your age distance is more than the minimum requirement. Maybe instead of 2 to 2.5D, you use 4D or 3D, 3 times the diameter of the rivet. So the clamping force of this rivet will not be sufficient enough to clamp the two workpiece together, and that create an age gap issue. So in this case, then this will also have, once you drill the hole here, you cannot plug it back, and what you need to do is remove the whole repair workpiece or redo a new one. So yeah, so you realize that everything's here are quite critical when we come to sheet metal repair. Right, these slides shows the type of defects that found in a countersunk rivet. The defects can be a wrong countersinking angle form. Okay, that means you use a wrong countersinking tools, cutting tools, or you cut the countersinking hole too deep or too shallow. If it's too deep in this case or wrong angle use, then you may have to replace the part that's been countersunk and replace it with a brand new part, which is rather expensive. If the hole is too shallow, of course, you can use the countersinking tool and carry out countersinking process again to ensure that the fasteners are flushed, right? Over here also mentioned about the dimpling. If it's too deep, okay, then you may have to change the workpiece, the sheet metal pieces, or if it's too shallow, then you may have to re-carry out the dimpling process. Solid shank rivets removal. To remove the rivets, you experience this when we carry out the practical work, but for the theory part, we will file the manufacturer head of the solid rivet universal head and do a center punch. Carry out a drill. Okay, why we drill? We will drill until the portion here You can see that's the drill cut mark, so that we can remove the manufacturer head by using a drill punch, and remaining shank will be punched out. So that is where you will remove the defective rivets. If it's a countersunk rivet, you will not need to file, but what you need to do is carry out center punch on the center of the manufacturer head, right? So you will practice this during our practical. Imagine I mentioned earlier, you install 100 rivets and you remove 99. So you will repeat 99 times of this process. And you realize that it's very time consuming, right? So what possible damage will you introduce, or will it occur when you carry out rivets removal? You may possible introduce hole damage. All right, what do you mean by that? Let me use a drawing to explain to you. Okay, so this is a circle. All right, dotted line circle, and the top view of it. What is this? All right, if you're looking down from here, or let's say put it this way lah, we look it down from here. What you see is actually the black line circle is actually your rivet diameter. All right, the rivet, and the dotted red line is actually the shank and the hole of the bearing, right? The hole of the bearing here. Okay, so if you actually you're supposed to drill a hole from the center here, center punch you drill. So you use the same size drill bit as per the rivet diameter. Example, this is the 316 316. Then your drill number, right? The drill number given to use to drill the hole is actually 11. Drill number B11. So 11 will give you the bearing hole of 0.191, which we mentioned earlier. 316 is 0.1875. So if you use a drill bit 11, actually when you drill and it's actually center, you will actually give you a correct cut. All right, no damages. But what happens if you misalign by putting your drill bit here, the second one, second dot here. Okay, I put a cross. What happen if you accidentally move away, just 1 mm away? What you will introduce actually what we call figure 8 hole elongation damage. And instead of removing rivets and replace the defective rivets, you're going to replace the whole top piece here, because once the whole damage, the whole top piece here, let me highlight it. Okay, highlight the whole top piece here is actually we need to require you to change. All right, because if you were to, of course you can install back, you can inspector won't be able to see it, but you'll introduce a latent failure on the structure. Okay, and is it fair to the customer? You think about it. So when we carry out drilling of defective rivets, you have to be extra careful. All right, it's irreversible damage. So I mentioned earlier, always do the right job, good job at every time. All right, so this requires constant practicing. So we haven't talked about it. One more thing is instead of using a same size drill bit, the recommendation from the documentation structure repair manual will say one size smaller. That means if it's drill bit number 11 to drill the hole, then they will recommend you drill bit number 13 or 12. It depends. All right, but some skillful workers, they are very skillful because numerous years of. Okay, sheet metal repairs. Let's quickly run through what type of repairs we carry out for aircraft structures. When we carry out any repair works, all right, the design is supposed to restore the original strength of the area, rigidity, and of course we have to consider the airflow characteristic. So how do we carry out repair damage assessment? We have to determine the extent of damage, cause and nature, then look out for any secondary damage. So what classified as damage? It can be a dent, scratch, abrasion, puncture, crack, loosening, or distortion. So that's what damages is about. So what cause damage to aircraft? Most of the time, we human introduce the aircraft incident or accidents events. So it can be collision, it can be corrosion, right? Improper treatment of the sheet metal, or didn't carry out proper painting, paintwork, all right, or you scratch the metal piece while installing, so that will introduce corrosion at a later stage. Combat type, yeah, combat, that's for military. Foreign object, that means you left any toolings or fasteners unaccounted for in the aircraft, especially the engine area where you ingest into the engine core, then that will be very expensive. Stress, the low aircraft landing and takeoff, differential stress loading, and of course heat stress. And so how do we inspect and investigate possible damage on the aircraft? The most common method used for all aviation airlines will be visual inspection, where inspectors will use a torchlight, inspection mirrors, even some magnifying glass, and to inspect structures that is not hidden, that means the aircraft structures. But you will need to use borescope. A borescope is actually a camera that, or a lens that will capture the internal part of the aircraft components and show it in a video format. So borescope is actually utilized for engine inspection, where to inspect the internal compressor blades or turbines or combustion chamber for any corrosions or defects. All right. If the area is damaged by fire or possible heat, then hardness testing will be carried out. Other various methods will be used by NDT department, which called non-destructive testing department. Will be magnetic particle inspection, eddy current, ultrasonic, X-ray, not mentioned here, X-ray, and dye penetrant or fluorescent tube penetrant inspection. So all these methods have its pros and cons and its effectiveness. So there's no one test method to cover all inspection. So the aircraft manufacturer will recommend various methods to tackle all the possible defects that will occur on aircraft. All right. So yeah, let's move on. This repair method is used to repair skin damage on the aircraft. The green portion here is the aircraft's original skin. So when there is a damage occur, the damage can be dent, out of limit dent, cracks, or even punctured. Then you have to remove the damage, cut out, and replace it with a filler, or they call it insert. So the filler or insert must be the same thickness and material of original skin. So how do you know what is the original skin material and thickness? You can refer to aircraft structure repair manual or aircraft drawing. Alright, the drawing will tell you is it 2024 T3 or 7075 T6 and 0.05 inch thick. So you have to check the documentation. So, and the repair doubler will be used and replace and restore the strength of the skin. Also act to secure the filler. The doubler is actually the medium where the loads are transferred. What do you mean by that? This is actually the original load. Because of the damage removed where the fillers is, then the load actually moves through the fasteners installed and to the repair doubler and goes back to the original part, bypassing the filler cord portion. Right? So one thing to take note is, let's say the skin itself is thickness is 0.05. Alright, 0.05 inch. So your repair filler or insert will be the same thickness. Now, the doubler itself will actually be one size thicker or 1 gauge thicker. So if the next available size on market is 0.061 inch, then my doubler thickness will be this. Alright, so this is a requirement. It is stated in the structural repair manual also. Okay, standard practices throughout all repairs, 1 gauge thicker. Right. So what do you mean by flush repair? Actually, this is actually the cabin and cabin portion, and actually this is the exterior portion where the airflow. When aircraft is flying, then you have airflow. So if you were to put your doubler, which is called external repair, then you actually create drags, turbulence on the skin area. So the this type of flush type repair actually reduce the aerodynamic issue, but the doubler itself is installed from the cabin side. The main problem would be when the inspector required to inspect the doubler condition after years later. The airlines or the maintenance repair overhaul company will have to remove seats, panels. Let's say assume there is a galley there, toilet there, you have to remove all these just to access the doubler plate. Why do we inspect or require to inspect the doubler after years of installation? Is due to the doubler can corrosion may occur on the doubler, or if assuming that the technician or the inspector missed out certain steps, it may introduce latent failure on the doubler. So as and when by law, inspection should be carried out on the doubler repair. And they will use the overlap patch repair, which is external. In this case, this will be the cabin, and this will be the exterior of the aircraft, the atmospheric area. So of course, this type of repair will create turbulence and form drags, but it is we'll put it in that way of aircraft safety, airworthiness. It is negligible because of fuel burn. But then again, in terms of inspection, it's easier because the inspector can just access from the outside without removing anything inside the cabin to check the condition of the repair doubler. All right. So just take note is all the repairs are either hold by a rivets or it can be high locks, right? So patch typically consists of two leg joints, one to pick up the load and one to return, as shown here. So the repair member must be 1 gauge thicker, same, and the filler, okay, let me highlight the filler. Here, highlight, yes, the filler in this case, okay, must be the same material and aircraft skin thickness. We will do a practical job on. So classifications of damage, there are 3 types: negligible, repairable damage, and damage that require replacement, right? Negligible damage does not affect the airworthiness of the aircraft. It's very minor, can be a very small nick, scratches, or dent that is within the limit. So how do we know is it within the limit or acceptable range? Will be the structural repair manual. So yeah, so you can just sand it off, file it off, and carry out necessary protection and release the aircraft for flights. Repairable damage. Okay, this type of damage will actually affect the airworthiness, in this case shown here. So it can be a tear or a impact damage. So what we will do will be carry out a repair to replace and form back the shape and restore the original strength as mentioned. If the damage is in this condition, then we will actually trim off this part. We will trim off this part and fabricate fabricate the original condition, fabricate the original shape, and install with fasteners. Alright, so damages can be repaired by patching, splicing, and insertion. Alright, so to restore back the original. If the damage is cannot be practically repaired or due to cost, it's cheaper to purchase the existing component, like this case. Then it's easier by ordering this part number, remove the damaged area, and install with only 3 fasteners. Do take note is the previous repair is actually damaged by repair, is require a lot of man hour to fabricate the parts needed, and the installation part also take longer compared to a replacement. So yep. So before any repair, AME, aircraft maintenance engineer, will evaluate the cost and nature of the damage. If the damage cannot be reasonably assumed, we need to seek manufacturer assistance or advice. Alright, so we will write to them. We call it EARN, okay, engineering assistance request note. We raise an EARN to the manufacturer and they will reply to us 5 working days later. Alright, any repair not approved by manufacturer, okay, must be approved by FAA or CAS. But having said that, this statement, normally the authority will look towards the manufacturer because the manufacturer has all the necessary data to decide whether this repair is as per the original loading requirements. So, alright, we have come to the end of Unit 2. Thank you.